Nitriding is the process of high-temperature diffusion saturation of the surface layer of a steel product with atomic nitrogen in order to harden the surface, increase wearing quality and corrosion resistance. The main types of nitriding include gas and ion plasma, as well as low-temperature and high-temperature nitriding. Low-temperature nitriding is used to increase the surface hardness of the product and its wearing quality, and high-temperature nitriding is used to improve corrosion resistance. The gas nitriding process is carried out in ammonia environment. At high temperatures, ammonia dissociates to form atomic nitrogen, which diffuses deep into the metal, forming nitrides of iron and alloy elements. Steels containing aluminum, molybdenum, chromium, and titanium are subjected to nitriding. The process is carried out on finished products that have undergone final mechanical and heat treatment. The hardness of the nitride layer is 1.5 2 times higher than that of the carburized one and is maintained when heated to temperatures of 550–600 centigrade degrees. The layer thickness is 0.3–0.5 millimeters. Nitriding is used to improve the surface properties of engine cylinders, pumps, gears, shafts, liners, and die parts.